Okay, welcome back to part 2 of the video. So now, looking at our arithmetic sequences, let's figure out what the structure, what the pattern is, so that we can come up with a rule to find any term. So we've been given a sequence, and we can look from 5 to 8 is plus 3, from 8 to 11 is plus 3, 11 to 14, 14 to 17 is plus 3, so my common difference is positive 3. So let's just fill in the table. For position 1, our term is 5. In position 2, our term is 8. In position 3, our term is 11. In position 4, our term is 14. In position 5, our term is 17. But let's look at what the process is behind it. So to get to my first term, I just start with my first term. So that's going to be a 5. Now to get to my second term, I take my first term and I add 3 to it. So I'm adding my common difference. Okay, to get to my third term, I'm taking my first term and I'm adding 3 to get to my second term, and I'm adding 3 to get to my third term. Then on the fourth term, I start with my first term, and I'm adding to get to my second term, and to get to my third term, and to get to my fourth term. And then for my fifth term, I start with my first term, and I'm adding my 3 each time. That's my second term, my third term, my fourth term, and my fifth term. So let's start to look at what this structure is. I can see that every single time I am starting with my first term. So I'm starting with a 5. Then I'm adding to it. If I look at the pattern here, I've got 1 3, and then I've got 2 3s, then I got 3 3s, then I got 4 3s. So 1 times 3, let's make that red. So 1 times 3, 2 times, we wrote 3, then we did our 3 3 times, then we did our 3 4 times. And really up here at the beginning, we did our 5, and we didn't do the 3 at all, so 0 times our 3. So now we've really, just from writing out what we were doing, have discovered our structure. Every single time we started with 5s, so we started with our first term, and then we know that we added to it some number, 0, 1, 2, 3, 4, times our difference. So I'm going to go ahead and put our difference times. So let's see if we can figure out what the pattern is. In position 1, it's a 0. In position 2, it's a 1. Position 3, it's a 2. 4, it's a 3. 5, it's a 4. So what I'm starting to see is whatever position minus 1 is what I'm multiplying my common difference by. So just looking at my structure of the process table, I figured out my formula for finding the nth term of an arithmetic sequence. Okay, so let's go ahead and just have you practice. What I want you to do is to do number 10 and 11 on your own. So before you pause your video, just discussing it, you're going to use the formula we just figured out, and you're going to simplify it down and then answer the question. So go ahead and do number 10 and 11 on your own, pause your video, and then check back for the answer and the explanation. Okay, there's really two ways you could have gone about this. I solved number 10 one way and number 11 the other way, or you may have come up with another method altogether. But on number 10, I went ahead and I plugged in my first term, and n minus 1 times my difference of negative 3. Then I distributed my difference. So I multiplied negative 3 times the n and negative 3 times the negative 1, combined my like terms, so I simplified my formula. Then, after my formula was simplified, I came down here and plugged in the 50 and got the answer. On number 11, I went ahead and just left my formula in the unsimplified version. I plugged in my starting term, I plugged in my common difference, I left this alone. And then I went straight to finding my 50th term. So I plugged in 50 for my n and then started simplifying it. So 50 minus 1 gave me the 49. 49 times negative 1 gave me negative 49. And my answer was negative 48. So it really just depends on how your brain sees it. There's no right direction to go. It's just how you see the puzzle working out easiest. Okay, for number 12, I want you to pause the video again to do number 12 and then check back for the answer. Okay, so welcome back, and I just plugged everything in based on what all I could fill out. Then I went ahead, because they gave me the Y version, or the Y answer, the 105, I went ahead and plugged everything in, simplified it, and came out with n equals 10. All right, so just like we had in geometric sequences, in arithmetics we also have recursively defined sequences, which is just the formula to find the very next term. So looking at number 13 and number 14, if we look at number 13, it's given us a formula right here that says a to the n minus 1, so our previous term plus 1. So right there it's telling us we're adding 1 to our previous term. So we know right away it's arithmetic and we're adding 1 to our previous term. It's not geometric. Then if we look at number 14, 14 and 15, we need to go ahead and first rewrite this formula. So crossing this out, we're looking for a sub n when a sub n minus 1 minus 3. And then on number 15, we're looking for a sub n when we've got a sub n minus 1 plus 4. So in both of these cases, we're dealing with arithmetic sequences, because in this case we're subtracting 3 from the previous term. In this case we're adding 4 to the previous term. So go ahead and pause your video and find the 2nd, 5th, and 10th term for each one of these, then turn the video back on for the answer. Okay, so on both of those I just followed the pattern and circled my 2nd, 5th, and 10th term.